As people are coming in, I'm going to go ahead and get started. I think a couple of people may still be on their way in. So I'll start by just introducing myself, and that'll give you a chance to find seats and so on. My name is Dave Thaler. I'm the partner software design engineer in the Windows networking group at Microsoft. This is my colleague, Peter Smith. He's a program manager in our group. Besides working at Microsoft, I'm also the active participant in the IETF, which is the Internet Engineering Task Force. That's the standard-setting organization for the Internet. I currently serve as a sitting member of the Internet Architecture Board, which oversees the standards process. I chair 2 working groups in the IETF, and so between my duties at Microsoft, where I work on the code base that we're going to be talking about today, I'm also one of the key members of the standards bodies, and so if you want to ask me any questions about Microsoft standards positions or the IETF or anything here, I was also the development lead at the time of Windows Vista when we rewrote the TCP/IP stack. And so I led the team of people that did that. So you can ask me questions about that too. But today we're going to be talking about Windows 8, in particular the Windows 8 runtime and the sockets interfaces to that. Now, just to let me get a feel for who we have here in the audience here, how many of you actually write code yourselves? Okay, raise your hand. Okay, almost everybody I expect. Okay, great, you're in the right place. Now for different languages, how many of you write in C#? Okay, I see, again, almost everybody. What about C++? Okay. A smaller number, but again, almost everybody. What about JavaScript? Okay, less than half. Okay, VB? Okay, so almost everybody is C# and then C++. Okay, as we go through the talk here, the samples and the demos that I'll be using, I'll primarily be using C# and JavaScript. But one thing that you should keep in mind is that all the samples and all the code that I'm talking about are accessible equally in all the languages that the runtime projects to. So all the languages that I mentioned, everything that I'm talking about, you can do in any of those languages. So pick your favorite language to raise your hand for, and it'll work. And I'll just pick one of those as an example as we go through. Okay, so with that, let's go ahead and talk about what we're going to talk about. So today we're going to talk about Windows runtime sockets and how this thing makes it easier, but still just as powerful as before, to write networking applications. And so we'll do that for about the first, third maybe. And then we'll jump into 2 of the brand new pieces of functionality that we've added in. In particular, we'll talk about the use of proximity discovery, proximity sockets, okay, which is a new feature. And we'll also talk about how you traverse web proxies using a new protocol called the WebSockets protocol that you may have seen in the keynote and some of the other talks. And finally, hopefully, by the end of this, you'll see examples and understand how you can get started and how you can use the runtime sockets APIs and how they relate to the APIs that you're familiar with. Okay. So when we look across the applications that are being written today, right, much more and more so, applications are becoming networked, right? If you look back 5 or 6 years ago, a lot smaller percentage of things dealt with networks, right? What do we have today that has no networking whatsoever? Well, maybe there's like Notepad, and there's a couple other things, but overall, a lot more things have some networking capability, right? Even something like a solitaire might have a leaderboard that you share with your friends, and so people are adding networking capability into a lot of different things that they weren't there before, right? And so this means 2 things. Well, first of all, it means that we have a lot more developers, a lot more applications that need to do something with networking. And a lot of those people might not be networking experts, and so we need to lower the bar and say make it accessible to somebody who just got this assignment to say, hey, you're in charge of the networking code. Would you make this work? Okay. But we also need to retain the power for those of you who are advanced networking users and know all the stuff that you know now. Okay. And so it's our job to kind of do both and make both of those groups of people happy. And that's what we're trying to do. So our hope is that the Windows 8 platform makes it straightforward, and hopefully you'll see that, to build a great application that people love and people want to buy or use or download or what have you. So we'll talk about how this makes your basic networking part even easier. Right? So there's a lot of stuff that was kind of painful in the past. You had to do a bunch of lines of code or a bunch of pages of code to do something that a lot of people had to do. And so we've tried to incorporate that into the platform now that there's some common tasks. And we'll look at some examples of that. And then we'll enable some new scenarios, as we talked about. We'll talk about the use of proximity sockets, and we'll talk about the use of web sockets as 2 examples of that, and a couple other things. And finally, again, just want to reiterate this. All the languages are accessible. Everything, all the functionality that I'm talking about is the same across all these languages. Okay, so how many of you have actually played Word Hunt now that it's been on your things? Okay, fair number. Okay, this is actually written by an intern who's sitting down here in the audience here. Now, what you may not have played with is the multiplayer part. And so what we're going to show you here, yeah, you go ahead and clap if you like the app. We're going to show you the multiplayer, and we're going to start in a state where we're already connected, and then later on we'll back up and show you how we got into the state. And so Peter here is a little faster than me, and so if you see any long words, just yell them out and I'll take them. Let's see, hen, and then, and so on. So what you can see here is that, on the right side we have, my words and his words, and we're keeping a score up here, right? So are we done now? All right. So this could go on for another 2 minutes, but the point is, we get this multiplayer game here, right? And it's using sockets underneath. And we'll just end the game here, and you can see, here's some words that were found, and who lost. Oh, I lost. Okay, he's better than me. All right. But I was talking at the same time, so unfair advantage. Okay, so that's the application that we're going to add some stuff to later on and show you how we got that into a connected state and so on. So this was written purely in JavaScript using the Windows runtime APIs. Okay, so for the rest of the talk, we're going to divide it up into about 4 sections. So first, we're going to talk about how it makes it simpler. Okay, so for people who might be new to the networking world, how they have to do less, or perhaps you've had to spend a lot of time on it, even if you're an expert, and now you have to spend less time doing the common tasks. We'll talk about the relationship to the rest of the runtime, okay, what you could do given that there's full runtime support for some things like streams. And then we'll talk about the proximity discovery and WebSockets. Okay, so those are our 4 sections that we'll go through. So let's start with the simplicity aspect. Now, before going into the simplicity of sockets, we first have to say, well, sockets isn't the only API. Okay, sockets is kind of your low-level nuts and bolts API, where there might be a simpler way to do it with a higher-level API. Okay? Given that there's new higher-level APIs, the first question and the simplicity thing to ask is, do I still need to use sockets? Or is there something higher level that I can use instead that just does all the work for me? Okay. So, for example, there's new things that you may have seen in other presentations and keynotes about, contracts, syndication, sync, upload and download in the background, that sort of stuff. And then you have various HTTP-based protocols, SOAP protocols, RESTful protocols, where you might not be programming to the sockets layer, right? You might be programming to, XML HTTP request or HTTP web request or HTTP client or something of that nature. Well, again, you wouldn't be using sockets there because there's something that's simpler that's tailored to what you want to do. So at the end of the day, what you're left with is that you still continue to use sockets if you're trying to build your own custom HTTP, non-HTTP protocol. Okay. So again, that's roughly the same as before, but now there's new APIs to look at. So before you're sure that you want to use sockets, all right. Now, if you're porting an application that's already a sockets application, right, that's kind of the no-brainer, right? But if you're writing something that's new, then you might want to look at these other APIs to say, is it going to be faster if I write to say, the syndication APIs or the sync APIs or the share APIs? Okay. Maybe I don't have to know networking at all, right, in the share APIs, right? We saw some examples in the keynote where you can write an application that doesn't have any networking code and yet can still interact with a network. All right, so we have a bunch of families of APIs, and here what we're looking at is the proximity discovery and sockets and WebSockets portions. Okay. There's various talks on all these other ones in here. So from the left to the right, we have sort of the high-level stuff that we talked about, down to the foundational, which is the nuts and bolts things, and then helper APIs, which you might use in conjunction with the foundational APIs. Okay. So we'll talk about proximity discovery, sockets and WebSockets, and streams. Now, I want to put this one up here, even though I think we all know it, because I want to use some terms in later on that I want you to understand what I mean by those terms. Okay. So we know TCP and UDP, and when I'm going to use the terms TCP-like and UDP-like later on, okay, here's what I mean, right? So as a reminder, TCP gives you a stream, right? There's no message boundaries, right? It's a stream of bytes that's reliable and ordered. And of course, UDP gives you message boundaries. There's no guarantees of ordering. There's no guarantees of reliability. Okay, so when I say TCP-like, we're talking about a stream. And when I say UDP-like, it's the datagram. Okay? And of course, lots of people build things on top of TCP and UDP. So here's our top-level socket classes that's in the Windows runtime. Okay, stream socket listener are the TCP protocol, right? That's the TCP initiator and the TCP listener. And of course, once you've done an accept, then you get a stream socket there too. Okay, so the stream socket is the connected data channel, and the stream socket listener is the control channel that's just your accept listener. Okay, datagram socket is the UDP one, then we have three that are brand new. The first two, Stream WebSocket and Message WebSocket, use the WebSocket protocol. Now, what's interesting is they use those, and they provide semantics that's similar to Stream Socket and Datagram Socket. Okay? So we have Stream WebSocket and Message WebSocket that work just like a connected or an established TCP or UDP channel, okay, in the sense that they both provide streams or datagrams. Okay? But underneath, they're using a different protocol that can traverse web proxies. And we'll talk about that a lot more later in the talk. But part of the point here is that out of these all have a lot of the same functionality across them, and what's different is which protocol that they're using. Okay? I'll also mention, and I'll come back to this later on, that in the WebSocket protocol, since it is going over HTTP at the bottom, which goes over TCP, of course, then when I say it's UDP-like, what I really mean is it uses datagram semantics in the terms of there's message boundaries. I can tell exactly how long the message is, right? But of course, since it's going over TCP at the very bottom, you still have the full reliability and ordering. Okay. But from application programming perspective, right, you have the message boundaries with Message WebSocket, and it's just a stream of bytes with Stream WebSocket. Proximity Stream Socket we'll also look at later on. This one at the bottom, it can either use TCP or Bluetooth, right? This is the one place that we have Bluetooth sockets. If you want Bluetooth, then you'd be using Proximity Stream Sockets. And this one is used for a peer-to-peer style of applications, say, within range of Bluetooth, but it's not limited to that because it can use TCP as well. And we'll talk about that more a little bit later on. Okay, so we'll keep this in mind that these are the sort of the 6 top-level socket classes. So what's simpler? Okay, well, let's take a look. Let's take an example of what you have to do today in .NET if you wanted to do something like, I have an application that might be streaming, for example, and I want to know how fast could it possibly get, right? I can't get any faster than my link speed, okay? So if I'm going to pay attention, I want the link speed for some piece of information, like maybe what codec I'm going to pick, or maybe what the maximum buffering size is, or something like that. I've got to write some code to say, given a connected socket, find me what the link speed is. How would I do that in .NET today? Okay. And this is the code that you'd use to do that in .NET. So here we're using a C# example. And so here we have the first thing that you do, starting from a TCP client class. Okay. We first have to say, so what's the IP address that is on the local side that we're using? And so we pull that out because we can't get to the interface directly, right? So we figure out it's using this particular IP address. So we'll get the local endpoint, cast that to IP endpoint. And then what we have to do is figure out which adapter that is. So how do we do that? Well, we have to enumerate all the network interfaces. So we grab all the adapters, and then we walk them, walk the list. For each one, we grab all the IP addresses on that adapter. And again, we're going to walk the list. So we walk the list, and we look for the IP address that matches the one that we were looking for. And then we've got it, and we can look on the adapter and pull out the property of speed. Okay? Now, if we were trying to do this in Win32 code, right, several people raise their hand for C++, okay, or C, right? That's a lot more than this lines of code, right? You got to call IP help APIs and so on. So it's more than this, but it's the same basic idea. Okay. So any guesses? How many lines of code do you think this is in the Windows runtime? Somebody guess. 3. 1. Okay. Who said 1? Okay. You are correct. Okay. Now, because you guessed right, I've got some M&Ms for you at the end here, so make sure you come up here and grab your treat here. So, yes, this is audience participation. There are rewards. Okay. So here what's going on is you see we have stream socket, okay, which is the equivalent of TCP client, right? We've got the connected socket. And what's going on here is we have client dot information dot. We get to the local host name or IP address. We go to the network adapter, and we can access the property. Okay. So what's going on here is we can traverse from one class directly down the list of classes or down the properties because it's all this connected graph. Okay. Now, could we still do it the last way that we showed on the previous slide? Oh, absolutely. You can still do that. You can still enumerate all the things and go and look it up yourself if you want. But you don't have to. Now you can do all that stuff in one line of code. Okay. So what this is illustrating is that it's easy to go from a connected socket to a rich set of other information. And I've just showed you one example here. Just to show you the depth of things that you can get to when I say a rich set of other information. Here's a relationship of classes. Now, this doesn't mean that you can't get to some of the lower classes more directly, right? You can enumerate adapters and that kind of thing, okay? But a lot of these were not connected before, okay? This is very hard to navigate to, say, from a stream socket down to the adapter property, which was just in the middle where you say network adapter. It's a property of that. Now, what's the color coding here? Well, if you look at the green classes, The green classes is what was available right now in .NET. Okay, this is what you could get to. Equivalent functionality exists in .NET today. The blue classes are things that are available only in native. Okay, so you had to p-invoke or just write in Win32 to get to the blue information. And the red information was not available at all. Okay, so if we use C# guys, then everything outside of green is new. And for you native code guys, everything in the red is new. Okay, so I hear you asking, so what is this new functionality of which you speak? So we'll talk about a couple things that I'm not going to talk about later on. And so I have some tokens here that you can search for docs or whatever. The top half of this corresponds to the blue classes, right, the stuff that was there in native before. And the bottom half of this corresponds to stuff that wasn't there at all. So let's walk through this top to bottom. Do you have an application where you need to get per socket bandwidth and latency statistics? So for example, maybe I'm doing that streaming application and I want to pay attention to how much bandwidth am I seeing so I can do adaptive codecs. Maybe I want latency information, which of these servers is closer to me historically. If you want all that information, all that stuff is there. The stuff was there previously, but only for native applications. It's the eStats, if you've seen that term before. So bandwidth statistics, round-trip time statistics, so the classes encapsulate that. And if you want more information, just take those tokens and go and look for docs on those class names. Do you have an application that wants to do things like keep per network information? So let's say I want to cache the default printer or maybe some proxy credentials or something on a per network basis. So as I come back to that network, I don't want to rediscover it or ask the user to re-enter it. I just want to look it up and just reuse it from my cache. Or do I want configuration information? Maybe I want to configure it one way when I'm at home and a different way when I'm at work or at a hotspot. Okay? And so if you want to keep track of that kind of information, you have to know, what's the network identifier and maybe some properties. Is this connected to the internet, or is this my home, or is it my work, and that kind of thing. And that's what the network item class is for. Moving on to the stuff that is brand new in Windows 8. Okay? You want to be cost aware. Okay? Now, there are some other talks that talk about this. If any of you were at Peter's talk yesterday, he talked a little bit about this. Cost aware, if I'm on a mobile broadband provider, right, am I paying by byte, or do I have a fixed plan, and that kind of thing. So this says, for my connected socket, is it connected across a network that is fixed, meaning I've already paid for it up to a particular cap? Is it variable, meaning every byte I send across this socket might be costing me something? Or is it unrestricted, basically, party on, like here at the network, here at the conference? So if you're interested in using that kind of information in your application, say to use lower res images or use a lower codec, that kind of thing, then you'd want to use connection profile and connection cost. Okay, this is like current information about how I'm connected right now with a socket, or through the interface because we're navigating down the graph. And then finally, if you're looking for more static information, like how does this correlate to my plan? Okay, well, I may be on a variable network right now, but am I, how close, what's my cap, and what's my current data rate, or what's my current usage out of that? Then you go all the way down to the bottom of the graph that I showed and use like data plan status and data plan usage. Okay, so that's all I'm going to say about these. For more information, go to those other talks, which I'll list up at the end, or the ones that have already happened, you can look at the video. So with that, let's get in some code, right? We're all coders here. Almost everybody here is a coder. So let's talk about how we actually use runtime sockets and what it looks like, right? How does it compare to, how does it compare to .NET sockets, and how does it compare to WinSock? Okay, so again, we'll start with C# as our example here. I think the most people raise their hands for C# here. So we'll use that as our first example here. We figured that was going to be most of you. So the first thing here is you'll see the namespace. Okay, so at the top of the file, we're going to be using namespaces Windows.networking and Windows.networking sockets. That's just so we don't have to repeat it a bunch of times. So we're going to declare a variable of type stream socket. Remember those 6 classes that we showed. Okay, so this one's going to be a TCP client. Okay. Now, for sake of readability, we're going to use a host name and a service name to connect to. So here, this example is going to connect to example.com, port 4554. Now, what you'll notice here is that example.com is being put into a hostname class, and I'll talk about that more on the next slide, why that is and what the benefits are there. And now that we have these 2 variables, we're going to pass them into an asynchronous connect method. Okay? And so we pass it into connect async, and we say, here's the host name, here's the service name or port number, and we say socket protection level is plain socket. Okay? Now, you notice the comment here that says connect using regular TCP, no security. Okay? Well, you get some security with TCP, meaning you've got to be on path or something, or to be able to guess the sequence numbers and so on if you want to inject data into it. But a lot of times now people are doing things like using TLS or SSL, over a TCP port, right? Not just with HTTP, but with various other protocols. So if I'm going to secure email or IM or what have you with SSL, right, that is something that is often desirable, and how would I do that? Okay. Well, if I have 132 code today, well, I might be using S-channel APIs or something, and it might be, I don't know, 20 pages or something like that. I don't know. It's a lot of code. Anybody done that, used S-channel? Okay. It's really complicated, right? Only one or two people, right, because it's that complicated, right? You put somebody on it, and you leave them there for a long time. Yeah. .NET is actually much easier, right? But it's still, what doesn't fit on a slide. Okay. Any guesses? How many lines of code does it take you to do it in the Windows runtime? Okay, this is your chance. What? 1, 2? Okay. Who said 1? You're almost right, but you're still not good. Okay. It's 1 token. Okay. All I did is I changed plain socket to SSL. Okay. So what that means is that we put the SSL support right there into the socket's classes. Okay. Did you say when I connect with this socket, use SSL? Okay. I don't do anything different. This is the client side. Now, you still have to support SSL on the server side, which I'm not showing you here, and for that, you can go to different talks. But for SSL on the client side, all you have to do is 1 token. So it's not even one line of code. But since you were closest and nobody else said 0, you can have some M&Ms too. So you can come up with the M too. Okay. So you like that 1 line of code? Good? There we go. Okay. So 1 token. Yeah. Okay. All right. So that's how you'd set up a connected socket. And you guys have seen the await keyword in a bunch of talks now, right? That means the code after this point will execute after the operation is completed. Okay, so let me go back to this hostname class. The purpose of the hostname class is to do a lot of stuff for you that otherwise would cause you lots of pain. Okay, and what kinds of things are those? Well, there's this IPv6 thing. There's this internationalization thing. If you're experts on them, you're one of a few. Especially internationalization. The more you learn about it, the more complicated it gets, really. I mean, I gave an IETF plenary talk on this, me and 2 other colleagues. It really is a complicated topic. It's easy to get things wrong. IPv6, right? We've already run through IPv4 address exhaustion at the top level, and so you might have people asking you, does this thing support IPv6? What do I have to do? What do I have to do? Well, part of the point of this is that, we haven't exposed directly an IP address class. What we've exposed is a hostname class that can use IP literals. Okay? So you don't have to worry about the data types, okay, of IPv4, IPv6. As long as you use hostname, all that stuff was handled under the covers. Okay? But if you want it, you can still get it because you still have literals. Okay? So this hostname class can be a DNS name, like in the example.com example we showed on the previous slide. It can be an address literal, 1.2.3.4, or the v6 example that's right there. In the internationalization case, let me just show you some of the pain that you'd have to go through if you didn't use this class. Okay? So let's use a couple of examples. There's 3 properties that are interesting on the hostname class. The raw name is just whatever you pass into the constructor. Right? So whatever you pass in, you get back. Okay? So that's why I show in the first column there. So that's what you might pass in. The second column is the display name. If you're going to put something on the screen or at a piece of email or whatever, and you expect a human to read it, then you want to use the display name field. Display name property. Okay. The canonical name, okay, is the thing that you might use for comparison or, say, for signing if you were going to do a crypto operation, that kind of thing. So let's walk through some examples here. So let's take example.com with 2 capital letters in it. Okay. Well, that's human readable, right? So the display name is the same. Okay. But the canonical name is the lowercase version, right? There's many different casing variations of example.com, and they're all the same machine. They're all the same host. Okay. So here, the canonical name is just the lowercase version, and that's the version that I might do if I were going to generate a signature or if I was going to do a comparison. Here's an internationalization example. Right? There's many protocols that are out there that are defined, or they're legacy, in the sense that they only can pass ASCII characters. Right? Well, that's not great for international markets. And so the IETF has invented this thing called Punicode encoding, which looks like this. It's not very human readable. To a human, it might look like garbage, right? XN -- some stuff. Okay, what is that? Okay. Well, that's the way of encoding the top-level domain for Russia in ASCII. Okay? And so if you're writing a protocol, or you're writing one end of a protocol, you might get in the protocol this string. What does that mean? Okay? Well, if you construct a host name out of it, it'll take care of the decoding for you and say, if I'm going to display this, this is example.the Cyrillic version of RU. Okay? So or RF, Russian Federation. And so here, that's what I would get for display, and I wouldn't have to worry about how this came in, as long as I constructed a hostname instance. The canonical name, of course, has the lowercase e there, and so this is an example where all 3 are different. Okay? Now, of course, even IP literals can have non-canonical forms as well, things with extra zeros and so on, so those get canonicalized as well. Now, since a very common operation is to just say, well, I want to compare the two canonical names for equality, the fastest way to do that is to just use the is-equal method. Okay. Now, what's interesting here that may not be obvious is that what you cannot do is you can't just do a case-insensitive comparison of the display name. You'll get the wrong answer. Okay. The casing comparison rules for host names are different than every other type of string. Okay, they're not the same it's not the same as a system invariant locale comparison. It's not the same as locale-specific comparison. It's a particular comparison that's defined by the IETF for comparing host names, okay, and a way that is global and so forth, because it has to work exactly the same in DNS. And so that's what's going on here in the is equal in the canonical name. It is the same as using the canonical name and doing a byte-for-byte comparison. Okay, so never use a display name for comparison. Okay, so hopefully now you should know why you might want to use the hostname class and what the benefits is it hides all that under the covers. So you don't have to worry about internationalization. You don't have to worry about IPv6. All the stuff that I walked through is stuff that's a peek under the hood that ideally you shouldn't have to worry about, right? Unless you're doing something super advanced that you're trying to do a lot of that yourself or whatever. Okay, most of the time you shouldn't have to worry about it. And now hopefully you understand a little bit why. The service name field is also a string. Right? You saw in our example it was 4544, or I think so. And what is that? Okay, well, a service name is a port number, but there's actually another thing that it is now. Okay? The service name as the name of a term is not new. Right? In Win32, we had APIs like getattrinfo that had a host name and a service name, okay, as a string, and this works the same way. What a service name is it's an IP port number or a string that corresponds to a port that can be resolved to one. And so let me first say what is the actual problem that using something other than an integer can solve. Okay. So when you're developing an application today, right, that's TCP or UDP, you need a port number. Okay. Where do you get that port number from? Well, if you're the server side, you're going to generate it, and the client has to learn it somehow, right? But where does the server get it from? Well, you usually have two choices today, right? You can arbitrarily pick one out of the air and hard-code it in there, which is probably anybody done that? Okay, maybe you don't want to raise your hand, but yeah. Probably in lots of your test applications work that way, right? Is you just pick one. Now, of course, the danger there is that the guy next door may have done exactly the same thing. And in the Windows 8, of course, when you put an application in the background, it may not die. It just goes into the suspended state. So you don't know how many of these other things there might be in this sort of suspended state that might be using the same port number as you, right? So the chance for conflict is actually fairly high if you just say, I'm going to pick a number and I'm going to hard code it. Okay, so it's not that great of a choice. Your other choice is to try to get a static port number by going to somebody like the Internet Assigned Numbers Authority. That's IANA. So you fill out this application form saying, please give me this port number. Here's what I'm using it for. And you get back either yes, or you might get back need more information, or you might get back, have you read the latest document that explains the problem and why you shouldn't be doing this and why you should be doing something else instead? So in other words, over the last year and a half, the rules for how you get a static port number have changed or are changing. The bar has gone significantly up, and so it's much harder to get a static port number now than it was, say, 2 years ago. Okay? If you're thinking of getting one now, either run fast or pay attention to what I'm going to say, because this might help solve your problem here. So what they've done is they've taken this bar for static port numbers and said, in order to do that, you have to explain why you cannot use a dynamic port number. Okay? Because they've looked at the port number space. They said, well, we've already run out of v4 addresses at the INA level. The next thing we're going to run out of is port numbers, because there's only 16 bits of that instead of 32 bits of IPv4 space. And we've got all these applications coming along, right? Every application, Solitaire and everything's doing networking. And so it's a lot harder here. And so they say, well, what you can do is you can get a service name, and that's first come, first serve. Right? So my app. Okay, great. You can have my app. You're the first person to ask. Great, no problem. Off you go. But that means that you're left having a dynamic port number, so it may be different on every listening machine, which means you need some way to map that name to the port number. Now, in the past, prior to Windows 8, what would happen underneath the covers of these APIs like getattrinfo is they would just look in the etc services file, which is just a static file on your local machine. What, of course, using that would have to be pre-configured, and so you can't really rely on that. The other thing that you could do is something called DNS SRV records or DNS service records. So you can put into DNS, here's a mapping from this service name to this port number. And then you can get that to be dynamically resolved, but that previously wasn't available underneath things like DNS.resolve and .NET or getattrinfo and native and so on. And so now in this connect async that I showed you, under the covers, it will actually, if it's not a number, right, like 4544 is just a number, right? If it's not a number, it'll actually go off and do the DNS SRV record query. And so the server side could have been using any port number we wanted without the client side having to know, okay, as long as the record was there in DNS. So that's the new functionality that's there in the Windows 8 runtime for service names, which works very well with the new IANA policies that say it's very easy to get a service name and very hard to get a static port number. Okay. So moving on to the data transfer portion, right? That's how you get connected. Okay? On the send data portion, now here you'll notice that there's the namespace that we're going to use here is windows.storage.streams. You'll notice the word networking is not in here. Okay? That's important, and I'll come back to this in a couple slides here. The socket has an input stream and an output stream, right? The send direction and the receive direction. So we say, hey, socket, can you give me a data writer? And we'll say in just a second what that is. So we get this data writer instance that we can use for sending. And using that data writer, you can think of this as being like a packet. Okay? I'm going to construct a packet buffer. Okay? And then I use however many write whatever APIs that I want to use to put stuff into that buffer. And this example is just putting in a single integer, okay, 32-bit integer, and I happen to like the number 42, so I'm putting in the number 42. Okay? And there's write string, there's write, everything else you can think of, all the base data types, and then some are there in this data writer class. So it's very easy to say, append this into the buffer. And notice I'm not doing any buffer size management here. I'm just saying put this into the buffer. And then I call store async, which does the actual send. Okay? So it's really easy to marshal stuff into the packet and then send it. Or if this is TCP, right, into the stream and then send it, right, in one message. Now, since I'm using an integer here, right, 42, you can say, well, the integer, we have Indian issues, right? Which byte order is it in? Okay. Now, by default, it's all little endian. And if you want to change that, then I tell the writer to switch the default byte order to be big endian. And at that point, all the writes that I do using integers where endianness matters, use whatever the last set one is. So I could set, 3 big endian ones, change it back to little endian, set 2 little endian ones, whatever I want to do. Okay. So it just tells the data writer to say all subsequent ones use the following byte order. Okay. So most of the time I'd set that once, say, at the beginning, and then just use that. Or if it's little endian, then I wouldn't set that at all. On the receive side, looks very similar. Okay. On the receive side, you're saying let's take the input stream, which is the receive direction. We're going to get a data writer class out of it. We tell the data writer class we're going to want to, in this example, we sent a request off to a server, and we're processing a response. And the response, let's say the response starts with an integer of 4 bytes. And so here we say get us 4 bytes because we know that it's an integer. So load async says wait until we have 4 bytes. Now that we have 4 bytes, we call read int32, right? Just like the write int32. Say give me that. And here again, I could have put the endianness in here. I could have said endian is big endian if it was. Another example is that maybe after that I have a bunch of data that I don't want to wait until the end. Maybe it's a stream of text that's coming in, and I just want to display it as it comes in. And so I don't want to wait, and I don't know how big it is ahead of time. Right? There wasn't a length in this example. And so here there's this partial flag that says, unlike the previous example where I kind of wait until I have exactly 4 bytes, okay, here I say, well, give me up to 64K, but signal me as soon as I have at least 1 byte. Okay, and then maybe I'll put it on the screen or something. Okay, so that's what the partial option is here. It says when I call load async, it's not a wait until I'm done. It's a partial is also fine. Okay, so this is perfectly normal for many streams applications as opposed to datagram applications. Okay. And then when we close the socket, how do we close? Well, just like in .NET, when it falls out of scope, the thing goes away. Of course, you can, if you want it closed before then you say .close, and you can close it. Okay, so let's recap what we've talked about so far. Okay, the paradigm is still using, the same things that you're familiar with in terms of open a socket, connect and accept and bind and that kind of stuff are all there, except for the names now it's connect async and so on. So it all uses the async model. So it's the same familiar paradigm that we're using. It's still the BSD sockets model, okay, but with a syntax that's tailored to the Windows runtime. It's consistent across all the languages. And it's easy to access the various information, right, to navigate from connected sockets down through that rich set of information. And finally, there's automatic support for complicated topics like IPv6 and internationalization. I said I was going to come back to the streams part. Remember the namespace that I said didn't have the word networking in it. There's a lot of stuff all across the Windows runtime that uses this data type of streams. Right? Here's a list of a bunch of them, and I'm not going to go through them right now. You can stare at them on the screen, and I'll put them on the next slide too if you haven't finished reading this one. But you can divide these up into a couple categories. You can have some of these that are like inputs, right? They're like stream sources, right? Webcams and microphones and that kind of thing. Some of them are outputs, output devices or output mechanisms like files and speakers and so on. And sockets are just things in this list. Can be used as an input. It has as an output. We saw the input stream and the output stream. There's also, and so that makes it really easy to say, connect me a webcam directly to a socket. Because they both speak streams. I don't have to do all the data marshaling. I can just say connect this stream to this stream and go. There's also things that might be thought of as being filters, encryption and compression, this kind of stuff. Those are also streams, and so I can say it's really easy to say go through a webcam, put it through an encryption, and then put the result out into a socket without having to do all the data marshaling. On the return path, I might do something like come from the socket, go through the decryptor, and send that to a video control. Right? I might have something that comes from the microphone, go through some audio compression, and then go out to a socket. Right? So the point is you can mix and match because they're all just streams. Okay? So if you're doing any of this, you don't have to use those write whatever APIs. Right? You can say they're all streams. Just connect them. Okay? So that's how Windows 8 runtime sockets are kind of integrated with the rest of the runtime in a straightforward fashion. All right. Now we're going to go on to some of the brand new stuff. Okay, proximity discovery, and then we'll talk about WebSockets. So proximity discovery, let's talk about what this is. Right, if you're writing a client-side application, right, you've got to have something to connect to. In order to do that, you've got to learn what it is that you're going to connect to. How do I get the remote endpoint information? Now today, things typically fall into one of three categories. Okay, the first category is you start from a host name, maybe typing it into an address bar or into an application. Okay? And so it comes from a human or some other way of getting a host name onto the local machine, and that gets resolved. Second category of applications might be using some server-based thing, like a lobby or a SIP server or something like that to do VoIP, that kind of thing. And the third category is I might be doing multicast to say who's around me in the same network and maybe pick one of those. Okay, so those are kind of categories that we think of today. And what proximity discovery is there's a fourth one into this list of tools in this toolbox. So we're going to show you the word hunt experience that we jumped into before and show you how we got connected. Except for first, we're going to show you what the experience would look like if we used host names. Okay? So Peter here is going to help me out. And I'm going to flip over. Okay. So here we have, I'm going to go back here. Okay. At the beginning of this screen here, okay, I'm going to select multiplayer. Okay, now, on the one that you have, you'll see it's tap and connect, which is where we'll get to at the end here. But it's called multiplayer here. And we get to the screen that says enter the name of the device to play again. So, hey, Peter, what's the name of that device?
Tablet.
Tablet, okay. Okay, no T there. And we'll connect there. Okay, so now we're back at the screen we've already seen. Okay, so let's talk about this experience here. Now, the game that Peter and I are playing, we're actually in the same room. Okay. Now, how tailored is it for me to have to ask him what the host name was and for me to type it in? Okay. Opportunity for typos. What if I had an international keyboard? We were from different countries or something. So it's not really tailored for this type of experience where we're right here. Okay. So this is probably not the right discovery mechanism for the word hunt application. Okay. But you see, that works fine. Okay. As long as we type it in correctly without typos and so on. So what might we do instead? Okay, proximity discovery is tailored for this type of scenario like we just did, where we're standing right next to each other. Okay? Now, what is proximity discovery? This is where the tap and connect keywords that you may have heard come from. Okay? Now, there's a type of radio called NFC, or near-field communication, that the range is about 2 to 4 centimeters or so. That radio is used for the initial rendezvous, the discovery of endpoint information. It's not used for the actual data transfer. Right? The actual data transfer, once you've connected, goes across TCP/IP or Bluetooth or Wi-Fi Direct and so on. So this little tiny radio is used for the initial rendezvous. Okay? It's used to exchange addressing information and then to initiate the connect across a different transport. Okay? So what that means is I only have to be within a couple centimeters just to do the initial tap, and then the connect happens, and then I can go anywhere. Now, I'll also mention, say, well, how likely is it for devices to have these kind of radios? Okay. Now, for all Windows 8 tablet form factor devices, it's a logo requirement. Okay. So if you're writing an application that's designed for use on this class of devices, this is guaranteed for any logo class device. Okay. I'll also mention for the machines that you got here, the NFC radio, if you're looking for it, I'll show you kind of where it is here. Kind of have a little sticky that's right here, okay, on the back. The sticky isn't on yours. That's my X marks the spot here. It's about right there, so it's on the back of the right side, okay, towards the bottom. Okay. So at the end of this, what you get back, at the end of the running when to connect, what you get back is you get back a connected stream socket. Okay. So you can think of this as like having two TCP listeners both waiting for an accept, right? Neither one's doing an initiation, right? They're both doing an accept, and then I do the tap, and then wham, what I get out is two accepted sockets. Okay. That's kind of the model that you see from the programming perspective. Okay. Now what's also going on here is that in the proximity tap and connect functionality, you don't even have to have your app running. Okay. In the example we'll show you, the app will be running. But you can also do this, say, with Word Hunt, when only one side is actually running. And so you do the tap, and it says on the other one, would you like to launch that application? Right. So it has that kind of built in, too. So it's a system service that takes care of that part for you. Okay. So that's kind of cool. And so if you want more information on these near-field radios, session 270, using near-field communication, which was actually yesterday afternoon, and so you'd want to check the video for that one if you weren't there. But that session talks about how you use NFC to talk to devices and things, where this session we're talking about app-to-app communication. Okay, so they're kind of complementary talks. But they also talk a lot more about the hardware aspects, too. If you want to have questions about that, I'd refer you to the people there. Okay, so here's some now we're going to jump into JavaScript. Okay, why am I using JavaScript now? Well, because the Word Hunt code that we looked at is actually JavaScript. Okay, that application was written in JavaScript, so we use a JavaScript example. Okay. Now, the first line of code here is actually optional, and the code that I'm going to show you actually doesn't have this. But just to show you the power here, I mentioned that once you connect, it may be using Bluetooth or Wi-Fi Direct or TCP/IP, and I can configure which ones of those I want it to work. If I don't want it to use all of them, right, they all default to be true. So if I say, I don't want this one to use Bluetooth because, say, maybe I wanted Peter to go way back there on the other side of the room and for him to have that side of the room against me, or if we're going to do something like that, we might turn off Bluetooth because it could go out of range if it went far enough. Or maybe we're doing too high of a bandwidth stuff, and so we might turn off Bluetooth there. Or you might have reasons to turn off the other ones. Say, maybe I only want it to be Bluetooth. Okay. So the code that I'm going to use, I'm just going to delete that line. Okay. So the next thing is we set an event handler for the tap. Okay, and here we're going to set that event handler to be peer connect progress event handler, and we say start. So this is what starts listening. Okay, so we're telling the peer finder to start listening and to call this function once an event happens. Here's our event handler. The event handler gets signaled whenever it goes through a state transition. Now in this example, I'm only going to pay attention to the completion state. Okay, so the first thing that I'm going to do is say, is the connect state equal to the completion state? Now you actually go through some intermediate states. Okay? You can say, oh, well, it's actually now done exchanging the information and starting to initiate the connection to the other side, or I've done exchanging information, and I've decided I've waited for the other side to connect to me. And so you can get that information out of the states, too. And we'll see that in the demo, I think. So in the connected state, now we can pull the connected socket out of there. And at this point, it's just a regular stream socket. Right? And so because, remember, we started off with two sockets that were kind of both in a listening state, or two applications that were both in a listening state. Now, some applications are sort of built with an assumption that one side is a client and one side is a server. Okay, now, one is the game host and one side is the game player, for example. And that actually is the case with Word Hunt. So when it did the host name connect, right, one side was clearly the initiator and the other side was hosting the game. Okay. Now here, since they're both equal in this sense, and the application required one of them to be designated as the host, we'd have to have some election scheme to have some tiebreaker to say, okay, I've got two accepted sockets. One of these is going to be the client. One of these is the server for purposes of the game. So one way to do that, which is what's shown in this example, is to say, well, I'm going to use the one with the lower IP address is going to be the client, and the one with the higher IP address is going to be the server. Right? There's other things I could have done. I could have paid attention to the pure states that came through in this event handler to say one of them came through an initiating state and one of them came through a listening state. And I could remember that and then use that. Okay. It was a couple more lines of code, so I'm showing the one that's slightly smaller. You can probably think of a couple other ways to do it too. But those would be two common ways to do it. And at this point, the functions that it's calling here are, these are functions that are in the sample code, right, or in the code that I'll show you here. So this one is the same function that would be called in a TCP hostname connect case, right? When it gets connected, the application calls onStream socket connected. On the accept side, it calls onStream socket accepted. And just to illustrate, this is the same way of just getting another socket, and we're calling exactly the same functions. Okay? So really, the proximity code part is everything kind of above the line until it gets to the proximity stream socket, pulling that out of the middle. Okay. So you've seen that code that's on the screen. Now what I'm going to do is I'm going to take that code that I just showed you, and I'm going to paste that into the actual application. I'm going to flip over here. All right, so we're looking at part of the code for the word hunt application. And again, this is JavaScript, and so this is, when that page that we're looking at is loaded, the one that has the, connect by name and so on. Okay, this is where it's setting up a connect handler for the connect event, the connect button, right? When I type in the host name and I click the connect thing, this is what's setting that up. And so you can see it was setting up a stream socket here and calling connect async, passing in the host name that I passed in. You can see it's plain socket. And then if it succeeds, it calls on stream socket connected. Okay? Everybody see that? That's what it was doing. Okay? Now I'm going to add proximity support to this application. Okay, so I'm going to add another event handler right here. So there's the first 2 lines of code that were on the previous slide, right, where it's setting the connect handler to be pure connect progress event handler and calling start. And then I'm going to put the function in. Okay, so here's that function that we just looked at in the previous slide. Okay, same line of code. And so I'm going to set a breakpoint so we can see what's going on. I'm going to set a breakpoint right there so we can see the events get signaled. Okay? And at this point, I'm going to go ahead and run it. Oh, wait, one more thing. Over here in our app manifest, okay, there's capabilities. Our capabilities take care of how do I get the right firewall ports open. Okay? Now, I don't want to have to write a bunch of setup code to do a bunch of firewall rules, because that's really complicated, especially if I have lots of different firewalls that might be installed and I don't know which one is there. Okay? So what have I done here? Right? Well, there's capabilities that you may have heard about in 785, and I'll give you a pointer to another talk that's later this afternoon that goes into a lot more detail about the notion of capabilities and how to debug and use them. You notice right down here there's one called near-field proximity. Right? It says it's required for NFC to connect with applications and so on. So I want to check that one, and that'll make sure that the firewall ports are open when I do this. Right? So now that I've done that, I'm going to go back here and I'm going to run it. I'll hit F5. We'll build that, deploy that, and I should start up here. Okay, so Peter's going to help me out here, and I'm going to say multiplayer. And now we're at the same screen. Notice we didn't do any UI work, so the UI still looks the same, but we've actually registered for both types of event handlers at this point. Okay, so now right Peter's got his little X here, and I got a little dongle on my laptop here that we're going to try to get these to here. And with luck.
Yep, I hit my breakpoint.
Nope, this one still doesn't do anything. If this one doesn't, we'll flip over to a video here. No, something weird's going on. So I think what I'm going to do is I'm going to show you the video of us running through this exact thing last night in this very room.
But it did work.
Yeah.
See, I got a breakpoint.
Yeah.
It broke into my code.
Why it did not here, I couldn't tell you right now. So we're going to go over to here. Okay, this is starting from the exact same point when we did our run through. And we'll put this up full screen here. And so you can see this is starting from the point where I've just pasted the stuff in, or I'm going to paste the stuff in. Okay, so we'll play it here. Here's where we stick in the first 2 lines of code. Okay. We'll scroll down. We'll put in the function. Okay. We'll set a breakpoint right there so we can see the breakpoint get fired. We'll hit F5 to say go. Okay, building, deploying, running. Okay. We'll go over and select multiplayer. At this point, we're tapping, and there we go, the breakpoint gets fired. So here, let me zoom in here. Oh, I hit Windows, okay. Here, when we looked at the connect state is currently 0. Okay, that kind of flashed by. 0 is the state of new peer found. You can see the little enum here. Okay, everybody see that? The state 0 is new peer found, so it's first started the tap. Okay, that's the state that Peter's is actually broken in at right now. Mm-hmm. So let me hit continue on. We'll hit F5, and you can see now, if we zoom in, oh, just missed it. If we zoom in, it's now currently at state, let's see, let's go back here in our little video here. We'll go back to about right here. Okay. Okay, so then it goes through to state, we passed it, 1 or 2. Let's see if we can go back to right here. Okay, so you can see here it's at state 2, which is connecting to device. Okay, so you can see there's a listening for connect, which is state 1, and connecting to device state, which is state 2. So one side, at the proximity discovery layer, has decided it's going to be the initiator, and the other side is going to be the listener, and it's already exchanged the IP address information. Okay, and so this is the side. In this case, it's gone through 2. Okay, so this is the connecting side. And so when it continues, it'll then hit state 3, which says it's now connected. Okay, that was a little fast there. We'll do it in slow motion for you. We'll go back to about right there. Okay, so we're at state 2. We hit F5. Okay, now it's in connect state 3. We pulled the socket out. We compared the canonical name, and you can see it's gone through the connected state because of the IP address. Now let me zoom in right. Let me zoom in right here. You can see here the canonical name. If you squint here, you can kind of see this is using an IPv6 address. Okay, which tells us it's actually connecting. It's negotiated the proximity tap with IPv6 addresses, and that's how it's doing the connect. And so when we look at the canonical name, we see the IPv6 literal there, which is what it did for the comparison purposes, to say which one had the lower string. Okay, and so when we hit F5 then, to continue, we somehow jumped back to the beginning. Okay, going back to where we were. So when we hit F5 here, okay, here's our IPv6 address. We hit F5, and we're in the application. And now we're back at the same screen as you've seen us get to. Now, what you've seen here, what's interesting is what's missing. Okay? What you didn't see is anything about a confirmation screen or which person would you like to talk to. And if you think about how you do the multicast discovery, right, you might be broadcasting some messages out, listening for messages coming in on the LAN or on the larger network, and then there might be a bunch of them. Let's say, all the people in this room, some portion of the people in this room might be playing that right now. Okay? Hope you're not. Hopefully you're paying attention. But you might be sending out messages. And go ahead and flip back to the slides at this point. Yeah. So at this point, if you were using multicast, then there might be a selection screen, which is, which one do I use? And so there's a lot of games that have like LAN play that you select, which is the host one that you want to connect to. Okay? Here you didn't see that, right? And the reason for that is because the selection mechanism is physical, right? I have to get within like 2 centimeters or 4 centimeters of that little radio right there. Okay? And so that's the manual choosing or the opting into this that says, well, I don't need an extra confirmation screen. I could have put one into my app if I wanted to, but there's really no need to. I've already done the intentional selection by doing that. Okay? And so this provides a better experience because once I've done that, then it jumps straight into the application. Right? It went right from the screen, okay, which had type in your host name. Okay? And so I might say for this application, well, this notion of typing in a host name, I can just yank that out now, okay, and just put another message there like please tap. And so when you look at the versions that you actually have, right, you won't see the host name experience. What you'll see is just a message that says tap and connect, and when you tap, wham, it goes right into the game. Okay. All right. Where am I? There. All right. Cool. All right, so that's
yes, it's cool.
Yes, it's cool. There you go. All right, thank you. So now let's talk about WebSockets. Okay, the problem with WebSockets, or the problem that WebSocket solves, is web proxy traversal. Okay, so here's something that most of us, or many of us, probably most of us, have experienced. Right, you have many networks that might only be connected to the internet through a web proxy. Okay, so say an enterprise network. You try to use TCP or UDP within that enterprise network. Sorry, won't connect. In fact, you probably can't even get DNS to resolve. Right? It gets blocked by the firewall because the firewall only lets traffic from the web proxy itself through. Whereas you might have something that's running in a browser, say, well, that browser goes to the web proxy and gets out to the internet just fine. Right? So what's going on is that we had things that had applications in a browser that could get through web proxies, okay, but they couldn't use sockets. Because there wasn't a sockets API. And you had applications that had sockets, but they couldn't get through a web proxy, at least not easily, right? You could write a bunch of complex code to use HTTP APIs to do a lot of the proxy discovery and authentication yourself. Anybody done that? Okay. I see about 3 hands. Okay, it's pretty complicated stuff. It's like writing to S-channel or something. It can be done, right? And if you have to do it, you can do it. Right? You can do that right now. But it's a lot of work, right? So you had browsers that could get through web proxies. You had apps that had sockets. And so WebSockets just takes those 2 pieces, puts them together, and combines the best of both worlds. So what you have is you have a socket that can get through web proxies. Okay? At the bottom, it's actually using HTTP at the bottom, or it starts using HTTP at the bottom, and that's how it gets through the web proxy. Okay? So it uses the same semantics as a socket, but with a WebSocket protocol in order to traverse proxies. So let me step out of the Windows 8 runtime for just a minute and say how much support we have across the Windows, across the Microsoft ecosystem, or the Microsoft products. The WebSockets protocol, just like TCP, is a client-server side protocol. Okay, you got some WebSocket client support, you got some WebSocket server support. There's WebSocket client support in the Windows runtime and IE10. So that means every place that IE10 runs, it'll run, not just Windows 8. For the server-side support, you got System.NET, IIS, ASP.NET, WCF. The point is, you pick your favorite framework, and we've done the WebSocket support for that. Now, here at Build, we're talking about all of these. In this talk, we're only talking about the Windows runtime WebSocket client support. If you want to hear about the other parts, for the IE10 part, you'd want to come to the talk. Tomorrow there's a chalk talk, diving deep into HTML5 WebSockets. Okay, and that covers the IE10 support, including the W3C standard APIs in IE10. For the server side, this one was yesterday, talk 807, building real-time web apps with IIS, ASP. It covered all the server-side stuff. Okay. So between the different talks this week, if you put those 3 talks together, you'll hit all the different parts of the WebSockets, APIs, and surface areas across the products. Okay, so again, we're going to focus just on the Windows runtime support for WebSocket clients. We're going to show you the sample code here, which is intended to look very similar to the sample code we started with in TCP. Okay, so we're going back to C#. So we're going to create a TCP-like WebSocket. Okay, remember what TCP-like means is stream semantics. So instead of saying creating a stream socket, we're creating stream WebSocket. Now our connect call, instead of connecting by host name and service name, we're going to connect to a URI. Okay, so in this case, here's the URI. All right. Now, the answer is on the slide, but how many lines of code do you think it is to use security with a WebSockets class? 0. Okay, good. See, there's no M&Ms for that because I told you the answer was on the slide. Sorry. But thank you for being the nice audience member. So here, the WSS, right, the second S there is the WebSocket secure, right? It's just that one letter, okay? So before it was one token, now it's down to one letter, okay, for WebSockets, right? That's because it's part of the scheme definition. So at this point, that socket is just like a socket that was created with TCP. It's just like a stream socket. Everything you do with one, you can do with the other. Okay, that's how easy it is. So you can easily start from an application that's kind of designed to be TCP and make it work with WebSockets very easily. And Peter's going to show us that in just one moment here. Now, in between those two, I might want to do some optional stuff. Okay? So what's happening here with the WebSockets protocol is that it starts using HTTP to negotiate through the proxy. It might have to authenticate. It might have to authenticate with the end server. At this point, it's just doing straight HTTP traffic. At some point, it's going to upgrade that connection, the underlying TCP connection, to a different protocol. And that's what the WebSockets protocol takes care of negotiating. And I'm going to upgrade to my app protocol, for example. Okay? Now, because it's just HTTP in the meantime, okay, until the connect async completes, okay, there's a bunch of HTTP handshakes going on as part of the protocol. So what that means is that I may need to use, or I may want to use, a lot of HTTP headers for those intermediate things. So for example, maybe my server requires a particular user agent string. Okay, maybe it requires some other custom headers. And so in between creating the socket and calling connect async, I have full access to set whatever HTTP headers that I want. Okay, I can pass in, OAuth tokens or whatever it is. Okay, so I can set a bunch of things. In this example, you can say we're going to set just one. Right, we can do this multiple times. Set one thing that says, set the user agent string to be my app in the HTTP negotiation. Okay? And that's so when it does the HTTP transfer, it'll just be using those headers. Okay. So at this point, I'm going to hand it over to Peter to show us what kind of stuff we can do with WebSockets.
The only talking part of the show, and we're almost out of time.
Yeah.
So what you see here is a very simple client app that I wrote that uses WebSockets to connect all the way over to my server, which is right there. And what my server is doing, and the reason you'd want to use WebSockets to connect the client to a server, is I'm actually going to control a little device. I'm going to control its position. I'm also going to asynchronously get information back from the device that will...
There can see that.
Yes, let me move it a little closer.
So what he's got here is he's got a little USB-controlled foam dart launcher.
And let's see. We move it to the right.
Okay, it's moving there. So the camera, okay.
You can see that we're getting asynchronous information back.
Yeah, if you look on the screen there.
I can point it. Oh, hey, cool, it's an ex-intern. We can fire at ex-interns.
Okay. Nobody's going to dare heckle now, right? Nobody's falling asleep in this area,
That's
right?
right. And the code for it, because David talked about lines of code, how many lines of code do you think it takes to send a command from this JavaScript client app, JavaScript but still an app, over to my server?
Very close. Okay.
It's actually...
Now,
well, hey, let me actually show you. It's just a hair more. It's 2 lines. Because you've got to do a write string, because all the commands in this case for the protocol I made up are just strings, like L for left and R for right. And then I have to do a store, because I got to actually send the data over the wire. The server, by the way, is C# using the full framework, 4.5, because we have WebSocket support in the full framework. And that should be done, right?
Well, you see over on the left side of the screen there where it says connected right now, as he moves it up and down, you'll see that change. Okay, as it moves here.
It's
not running?
It's hopefully, let me
connects?
reconnect.
Okay,
And there
it's
connected.
Okay. You see as it's moving, you see where it says direction left. Okay.
And position at
and
the
position.
top.
Okay. Those are the asynchronous updates coming down from the server in real time. Okay, without him having to do any request response protocol to do that.
That's right. I'm getting about 1 message per second, because that's the polling that I chose for this particular protocol.
Okay. And so this is what you can do through a web proxy without having to do complicated techniques like long polling and so on. If you want more details on the advantages and simplicity, that's what the Chalk Talk 373 is about tomorrow, and as well as what the IIS-related one there. Now, you see Amy there on the audience. Now, do you guys really want to see this thing shoot? Okay, everybody. Okay, who wants to see it shoot? Raise your hand. Okay, the guy back there just raised his hand. Maybe over in his direction, a little higher. Okay, all right. Is that all the way up? Maybe a little bit higher. Is that all the way up? Okay.
That's okay.
Great. Okay.
There you go, a little higher.
Okay, there we go. That's okay.
Ready?
You ready? Okay, go for it.
I'm trying.
Tick, tick, tick,
There
tick,
it
tick,
goes.
tick, 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 tick.
Takes a little while. Build, suspend.
Whoa! All right. Okay.
And so, because I need my dirt back, if you bring it back, I've got a candy bar for you.
The candy bar is way more useful than that. You can bring it up at the end. It's okay. All right. Go ahead and flip back to
Yep.
our here. So let's wrap up here. So what we've just seen is we've talked about 4 areas. We've talked about the simplicity, right? This is where we showed you how easy it was to get information on a socket that was very difficult to get before. Okay. We talked about the streams integration, how it was easy to connect, say, webcams to streams and so on. We talked about proximity discovery, right? This is where we did the tap and connect stuff that you can actually do with your own tablets, right? You can use the word hunt application that has that built in, right? Just remember where the radio is in the back if you're going to try it. And we talked about web proxy traversal, which is where you got shot at, so pretty fun. Okay. So with that, here's the sessions that I've talked about. I think I've mentioned all of these except for the last one. The 785 was one that we talked about cost information. That one was yesterday. 270 is the hardware and device talk about the NFC radios. That one was yesterday. 807 was also yesterday, which was the server side of WebSockets. Okay. 373 is the one that's tomorrow. That's the Chalk Talk that talks about the IE portion of WebSockets and goes down into how the protocol works and in relationship to long polling and so on. And then the last one here I haven't yet talked about, except for I referred to it once. This is 588. It's talking about debugging. And this is where, among other things, you'll hear more about those capabilities that obviate you from having to do firewall work and setup and so on. Okay, that's one of the topics that they'll cover in the debugging ones, the notion of capabilities and how we pick that proximity communication capability. And so if you're interested in more information on that, you go to that talk. I think that's the last session today. Okay. And with that, there's other information. You can find the word hunt application, and we're available for questions. Probably going to be at the booth since we're already over time. We won't take questions in real time now, or you can come up afterwards. I don't think there's another session in here. So with that, thank you very much for coming.